Hello and welcome to Mrinal's Math Tutorials. This is Binomial Expansion Part 2 tutorial, and today we're going to learn about binomial expansion again, but we will be looking at some difficult questions, some complex problems which you will have in your AS level maths or IB maths. So let us look at the first example. Again, all the questions that I'm going to discuss in this tutorial are from your past paper questions. So the first question over here is the coefficient of 1 over x in the expansion of 2x plus a over x square to the power of 5 is 720. Find the possible values of the constant a. Now in my last video, I had explained how do you calculate the coefficient of 1 over x, or for that matter any coefficient, using the general formula. Now in this question it's given to us that the coefficient of 1 over x is equal to 720. So the first step is going to be to calculate the coefficient of 1 over x in this expansion. Let me remind you what is the general term in a binomial expansion. The general term is given as NCR a to the power of n minus r, b to the power of r. Over here your n is going to be 5, a is going to be 2x, and b is going to be a over x square. So I'm going to now calculate the coefficient of 1 over x. If you remember, you could write down an equation to calculate this coefficient. So now first let us try to substitute what we have over here. So we are having n is 5. We need to find r. A is 2x to the power of 5 minus r. B is a over x square to the power of r. I'm going to leave in the description box the link to how do you calculate the coefficient of 1 over x, or also you can follow along this video again to remember or revise how to calculate the coefficient of 1 over x. So I'm just going to ignore the coefficients of x, so ignore the 2 and a. So we're just going to work with the x and its powers. So we are having x to the power of 5 minus r, and this x is in the denominator. So if you take it in the numerator, it's going to be x to the power of minus 2, everything to the power of r, and we are looking for the coefficient of 1 over x. That means the power of x is going to be negative 1. Use the rules of indices and set up an equation in R. So that gives me x to the power of 5 minus r minus 2r is equal to x to the power of negative 1, or 5 minus 3r is equal to negative 1, which is 6 is equal to 3r, or r is equal to 2. Once you have obtained the value of r, go ahead and substitute the value of r in this general term. So I'm going to substitute that now. So we have, once you have found out the value of r, go ahead and replace your value of r in this general term that you have obtained by substituting n equal to 5. So you're going to get the coefficient of 1 over x is equal to coefficient of 1 over x is equal to 5c2 2x to the power of 3 ax square to the power of 2. That gives me 10 times 8x cube times a square over x to the 4th. That means it's going to be 80 times a square times 1 over x. So we are just interested in the coefficient. This coefficient is going to be equal to 720. The coefficient of 1 over x is equal to 720. So let me make some space over here. So 80a square. Alright, so 80a square is the coefficient of 1 over x, and this coefficient is equal to 720. So we are going to now equate 80a square is equal to 720. So a square is going to be equal to 9, and square root of 9 is going to be plus and minus. Keep that in mind. So plus and minus square root of 9 gives me a is either 3 or a is equal to negative 3. So we are done with part A. Find the possible values of constant A. Now look at the next part. The next part is asking you, hence, find the coefficient of 1 over x to the power of 7. That means you got to replace the value of a over here as positive 3 and negative 3, and hence calculate the value of 1 over x to the power of 7. Alright, so let us do that. So we are having our expansion as 2x plus a over x square, and I'm going to substitute this as 2x plus 3 over x square. This is the first one, or it could also be 2x minus 3 over x square. Now I want to find out, so I want to find out the coefficient of 1 over x to the power of 7. So that means in my general term I'm going to have 5cr 2x to the power of 5 minus r 3 over x square to the power of r. So let us calculate first the value of r, and then we could go back and replace this as minus 3 over x square once and plus 3 over x square for the second time. So let us calculate the value of r. So set up your equation. X to the power of 5 minus r times x to the power of minus 2r is equal to, so we can put small brackets over here, is equal to x to the power of minus 7. So x to the power of 5 minus r minus 2r is equal to x to the power of minus 7, or 5 minus 3r is equal to minus 7. That gives me 12 equal to 3r, or r is equal to 4. Once I have obtained r equal to 4, I am going to calculate two coefficients of 1 over x to the power of 7. So we are having 5c4 to x to the power of 1, 5 minus 4 is 1, and 3 over x square to the power of 4, or 5c4 2x to the power of 1 minus 3 over x square to the power of 4. Notice that the value of a was positive 3 or negative 3. Now that you have obtained the value of r as positive 4, an even number, it doesn't really matter whether you choose a as positive or a as negative, right? So it's not necessary for you to write these two different equations, since the value of a is positive or negative. You need to focus on the power. The power here is an even power, so it doesn't really matter whether you choose -3 or +3, you're going to get the same answer. So you could just ignore this. So let us calculate the coefficient then. This is going to be 5C4, which is equal to 5 times 2x times 3 to the power of 4, which is 81 x to the 8. So 81 times 10, which is 810 times 1 over x to the power of 7. So your answer is 810. Let us look at one more example now. Now in this example, we have the coefficient of x to the 4th in the expansion 3 plus x to the 5th is equal to the of x square in the expansion of 2x plus a over x to the power of 6. So what you need to do is calculate what is the coefficient of x to the 4th and the coefficient of x square. So here it's very easy. We don't need to set up an equation to find the value of r, because we want the coefficient of x to the 4th or x square is just going to be NCR, which is 5C4. The value of r is going to be 4 because we are looking for coefficient of x to the 4th. 3 to the power of 5 minus 4, which is 1, and x to the power of 4. This coefficient should be then equal to, we need to find the coefficient of x square here, but in this one is, you're having a fraction here, therefore you'll have to set up an equation to calculate the value of r. Let us complete this one. What is 5C4? 5C4 is 5, so this is 15x to the 4th. Yeah. Now in this expansion, the second one, which is 2x plus a over x to the power of 6. Let us calculate the value of r that should give you coefficient of x square. So that is going to be 6 CR, 2x to the power of 6 minus r, a over x to the power of r. So I'm going to set up my equation. X to the power of 6 minus r, x to the power of minus 1 because the x is in the denominator, to the power of r is equal to x square. So x to the power of 6 minus r is equal to x square. That gives me 6 minus 2r is equal to 2, or 4 is equal to 2r, r is equal to 2. Once you have obtained the value of r, go back and substitute in this equation over here. So you're going to get 6C2, 2x to the power of 4, a over x to the power of 2. So calculate 6C2, that's 15 times 2 to the power of 4, which is 16, x to the 4th, a square over x square, 15 times 16, that is 240, a square x square. So now you have two things over here, coefficient of x square and the coefficient of x to the fourth. So the coefficient of x to the fourth is equal to the coefficient of x square. So 15 should be equal to 240 a square. So divide by 240 on both sides. So 15 divided by 240 is equal to a square. That gives me a square equal to 15 divided by 240, which is 1 over 16. So a is square root of 1 over 16. That is 1 over 4. Remember, the question has specified the a is a positive constant. Therefore, we are just going to take the positive square root and we get a as 1 over 4. Alright then, that's it for today's tutorial. Make sure that you like, share and subscribe to my channel, and remember to press the bell icon to get more updates. We will be looking at few more examples on binomial expansion to cover this topic completely, and then we will be solving random questions from the past paper which will help you to gain confidence in this topic. Thank you for watching.